It is late in the evening. You are completely exhausted after a long day. You just want something simple to eat. You ask your digital assistant for help, but it shifts the burden back to you. It asks about your cuisine, your budget, and your location, a string of clarifying questions that you have already answered a dozen times before. You eventually give up and do the work yourself. You switch between 3 different apps to search, filter results, and compare delivery times manually. The problem here is not a lack of artificial intelligence. It is a lack of personal context. Your phone knows your preferences, but your assistant is not built to access them. Efficiency changes when the AI already possesses your visual context and historical memory before you even speak. Usha is an on-device personal context engine. It uses conversational cues and environmental data to turn what you see and hear into direct, real-world actions. This architecture transforms the smartphone into an active agent that works on your behalf, using your specific history to bypass the friction of a standard search. Let's route that same tired and hungry prompt through Usha's internal pipeline to see how it actually reaches a conclusion. First, local speech recognition extracts your core intent, finding a meal. Simultaneously, the interaction state analyzes your tone, recognizing you are tired to prioritize lighter options. It then queries local memory, retrieving your vegetarian 300 rupee preferences, automatically completing your request. Now, the agent orchestrator selects a deterministic tool from its library. It maps your preferences to a delivery API, identifies a specific paneer bowl that fits your budget, and prepares the exact execution command. Even with this level of autonomy, Usha requires a human in the loop. It presents the plan for approval, executing the order only after you provide an explicit confirmation. Standard AI assistants route even minor tasks to massive, power-hungry cloud models. Usha acts as a router, sending tasks to the most efficient local models. Speech goes to Sherpa Onyx, vision to Paddle OCR, and reasoning to a lightweight Qwen 3 model. This entire stack resides directly on your hardware. This engineering ensures your data stays private by default. Because the processing happens locally, your personal context does not need to be uploaded to a cloud service to be useful. Usha also scales beyond the phone. Suppose you are looking at a complex architectural diagram and need to compare it against the project files on your computer. A feature called Office Kit enables adaptive compute. It bridges your physical environment with your digital workspace. The phone handles the initial vision capture and OCR. When the task requires heavy document reasoning, the system dynamically routes that specific workload to your laptop's processor. This workflow allows the AI to utilize the ambient compute power of your entire hardware ecosystem, selecting the best tool for the complexity of the task. Usha is purposefully built to fail safely. If the system encounters an uncertain voice command or a blurry image, it pauses and asks you to confirm its interpretation rather than guessing. If the internet or your workspace connection drops, the system remains resilient. It automatically falls back to a phone-only mode, keeping your most critical local tools accessible. This refusal to silently hallucinate is a key marker of a mature system. It ensures that the AI remains a reliable tool that respects the boundaries of its own recognition. Usha serves as a persistent, context-aware proxy, bridging your intent and your digital world from the privacy of your pocket.